Good morning, ladies and gentlemen. Today we're going to be focusing on chemical reactions, and we're going to be learning why the single replacement reactions happen. What conditions are required to make it happen? So this is going to be our sole focus today. Okay, single replacement. And this is going to be a short presentation because there's not that much new information. So the general equation for single replacement is A plus BC becomes B plus AC. The A replaces the B and takes over as partner. Okay. The question is, why is that allowed to happen? Okay. Let's look at some single replacement reactions from yesterday. Let's look at 7 and let's look at 8. Both of them are single replacement. If you look at them, though, they are slightly different in the sense that in number 7, we have aluminum and zinc. They're trading spots. Those are metals. And number 8, you have chlorine trading places with the bromine. Those are nonmetals. You can have single replacement reactions where the metals are trading places, and you can have it where the nonmetals are trading places. Okay, they can both happen, and they're both still considered single replacement. But let's focus on 7 for now. So in 7, you have aluminum replacing zinc. Why is that allowed to happen? There's this thing called an activity series. And the activity series tells you which elements are more reactive than others, basically. Okay? The higher it is on the list, the more reactive it is. In this list, it's just the metals, but they also have one for non-metals. Okay? There's a non-metal activity series and the metal activity series. The higher it is on the list, the more reactive it is. So in number 7, we're focusing on aluminum and we're focusing on zinc. Aluminum is higher on the list than zinc is, meaning that aluminum is more reactive than zinc. What that means is that aluminum needs the partner more than the zinc does. If you remember, reactions take place because your final product is more stable than what you have in the beginning. Aluminum is more angry being alone than zinc is being alone, if that makes sense. Zinc can tolerate being alone more than aluminum can. Aluminum needs the partner more than zinc does. So this is allowed to happen. Zinc does still want the partner, but aluminum just needs it more. Okay, so having aluminum be partnered up with the chlorine and having the zinc by itself is more stable than the opposite. Okay, so because aluminum is more reactive, that means it needs to partner more. It's allowed to kick out the zinc. Okay, and that's why these reactions happen. If the element that's by itself is more reactive than the one partnered up, it is allowed to. The reaction is allowed to happen. And just make sure you're comparing the right stuff. Like it will be pointless to compare aluminum and chlorine because they're not the same thing. One's a metal, one's a non-metal. So if the element that's by itself is a metal, you need to look at the metal partner. And number 8, the element that's by itself is a non-metal. So we need to look at the non-metal partner. So let's look at number 8. In number 8, you have chlorine kicking out the bromine. And for this one, we have to look at the activity series for the nonmetals. Whereas chlorine is higher on the list again than bromine is. Because chlorine is higher on the list, that means it needs to partner more, which means the reaction is allowed to happen and it's allowed to kick out the bromine. And now you end up with bromine by itself. Okay? So that's all today is. You're going to be looking at a few reactions and you're going to tell me, is the reaction going to happen? Yes or no. And you can figure that out based off the activity series. Okay? That's how you know if the reaction is going to happen. And I'll do one with you that where it doesn't happen. Okay. So the type of reaction, you should all know what the type of reaction is. It's what we're going over today. It's the one we highlighted in the beginning. So that's the type of reaction. And will the reaction move forward? Yes or no? You just need to look at the activity series and the elements involved. So I'm going to do number 2 because I know for a fact number 2 cannot happen. So in number 2 we have copper. Copper is by itself. Copper is a metal, which means in this one we need to be looking at the other metal. So in this case we're looking at copper and we're looking at aluminum. Let's go to the activity series. Aluminum, we already see is there, but where's copper? Copper is all the way down here. So aluminum is a lot more reactive than copper is. So because aluminum is a lot more reactive, that means the copper cannot kick out the aluminum. The copper cannot kick out the aluminum because the aluminum needs the partner more, okay? Aluminum needs the partner more. So this reaction cannot happen. So it has it as if it will happen, but it's up to you to determine whether or not it will. So this, the answer is no. This cannot happen. Cannot. And that's what you're going to be doing for the rest of them. And just make sure you're comparing the same things, okay? So in this, like in number 3, bromine is the thing that's by itself. Bromine is a non-metal. So you need to look at the non-metal partner, which in this case would be the oxygen, okay? And oxygen is also on the list, all right? That's it for today. Thank you for your time, guys. I wish you the best. Hope you guys are all good, all right? Today was a short one, which is 9 pace. Okay. Take care, guys. Have a good one.